So some of you have expressed that you're still having trouble. Maybe once you have your chi-squared table set up, um, you're having trouble figuring out how to tally. And you're getting numbers in weird places because we didn't do a lot of ones where you actually had to tally. So I'm going to show you this example. So before you start, you need to have your table. So I'm using the data from Mr. Moss-Emery's example, and I decided to do a 2x4 table, which is the example that's in the video. And so in my table, at the top, I have literacy rate, and I'm just going to use the mean. So anything that is less than 84.78, call it 84.8, goes here, and anything greater than or equal to 84.8 would be in this column. And then down the left side, I found the 5-number summary, which you should have found anyway when you're doing your stats. You might have to add in the quartiles if you didn't do that. And what I'm going to do is go from 0.12, including 0.12, to less than 0.41. Okay, so if you want to make that be an inequality, so x is greater than or equal to 0.12 and less than 0.41, and then 0.41 to the next, which is 0.76, not including 0.76, and then 0.76, starting at 0.76 and going to 1.59, and then 1.59 to the max, which is 3.78. Okay, so there I have a 2x4 table that's with as much data as you guys have. That should be pretty safe. And so now I sorted by poisoning deaths. Again, that is in the video helping you set up the table. And now I just need to tally where they go. So the first one, the first all the way up until 0.41, so all the way to here, these will be in the first row because the X, or the poisoning deaths, falls in that category. So I just need to tally where the Y goes. So the first one is bigger than the mean, goes here. Second one, bigger than the mean. Third one, bigger than the mean. Fourth one, bigger than the mean. Fifth one, this is one that is not bigger than the mean, so it would go here. Bigger than the mean, bigger than the mean. Okay, so as you're tallying, you might just make a note of the ones that aren't, especially if they're kind of segregated. So in this one, the only other one that's not bigger than the mean is that 57. So only two, you're only going to have two in that first box. Okay, and he doesn't have as many in his list, and I can't remember how many are in that first quartile, I think 20. So when you're all done tallying, you're doing this on a piece of paper, when you're all done tallying, you would have 2 in this box and 18 in this box. Okay, and then we can move to the next set. Which I didn't copy the whole list, but the next set would fall in the second row. Because though the X is, we're looking at the X is between 0.41 and 0.76. Obviously, there's 20 values. So again, I'm just looking to see which of them are above the mean. That'd be the faster way to tally. Or which ones are below the mean, either one. So this is the only one I see right here that's below the mean. So that would go in this first box. Those other 6 would go in the second box. Okay, and so you're just going to keep tallying that way. Now, the key is when you're done, let's say I end up with, I don't know what the numbers are, but these all would add up to 20. The key is you need to test this in your calculator. Okay, so put that in the matrix. and do your chi-squared test. And we don't care what the chi-squared value is right now. You need to go to matrix B and make sure the expected values are all greater than or equal to 5. If any of them are less than 5, then the chi-squared test is invalid. It's not, you can't make a conclusion, it's invalid. You can't use chi-squared. And so the best way to change that is to change your original boundaries. Now you guys have enough data that I'm guessing you're probably going to be okay, but in some cases the data is really bunched up. Like if you notice, it's heavy on the above the mean over here. So maybe the easier change would be, instead of using the mean for poisoning deaths, you would use, or for the mean literacy, you would use the median. And so whatever the median is for the second list, you could use that as your boundary and check. Maybe you have some outliers in your data, and so you want to use the median and make that better. If your data is bunched up, I would use the mean. If your data is all spread out, you definitely want to use the median, because this table has to be valid. We will check this table, and if it's invalid, then your whole chi-squared test is invalid. Okay, so hopefully that helps you. This table should be done just like this, on a piece of paper, tallied up, and then when you actually have numbers in your table, then you can go to Excel and show the work, or just show the work in your actual document using the right form. Okay, hopefully that helps.